In this video, we'll be learning about the domain and range of a function. The domain of a function is the set of real number inputs that you can plug into the function. The range of a function are the possible real number outputs that you can get from the function. So the domain consists of numbers that you can plug in, and the range consists of numbers that you get out of the function. In this video, we'll be focused on finding the domain of a function. We'll talk more about the range of a function once we learn how to draw the graphs of functions. So let's take a look at some functions and let's try to find their domains. Our first example is the function f of x equals square root of x plus 3. In order to find the domain, we want to think about what numbers can we plug in, or maybe what numbers can't we plug in. For example, we can ask ourselves, can we plug in a number like x equals -5? Well, if we try to evaluate f of -5, we end up with square root of -5 plus 3, which simplifies to square root of -2. We have a problem here because there's no real number that squares to -2. So since we can't take this square root, we say that -5 is not something that we can actually plug in. So -5 is not in the domain of our function. Well, what about other numbers? Maybe we can ask ourselves, can we plug in the number like x equals 3 into the function? Let's check by computing the output. The output f of 3 would be square root of 3 plus 3, which is square root of 6. While square root of 6 is not a whole number, this is an operation that we can perform. If we try to type it in our calculators, we get an irrational number that's close to 2.45. All this is to say that when we plug in x equals 3, we can perform the operations of the function and get a valid output. So 3 is in the domain of our function. Now, we don't want to just keep testing random numbers to see if we can perform the operations. To find the domain, we just need to make sure that we're not taking the square root of a negative number. What we need is that the stuff under the square root is greater than or equal to 0. For our function here, the stuff under the square root is x plus 3, and we want this greater than or equal to 0. This gives us an inequality that we can solve to find our domain. If we subtract 3 from both sides, we see that our x value must be greater than or equal to -3. So as long as my input x is greater than or equal to -3, the stuff under the square root will be greater than or equal to 0, which means we can perform all of our operations. Let's illustrate these x values on a number line, and then we'll be able to write down the domain in interval notation. So on the number line, let's place -3, and what we're interested in is -3 and all x values to the right of it. So in interval notation, the domain of our function is -3 to infinity, including -3. Let's take a look at an example with another function. In our example here, our function is f of x equals x squared minus 2. And again, we want to figure out the domain for this function, meaning we want to think about all the real numbers that we can plug into this function, perform all of the operations, and get a valid output. Well, let's think about what operations are being performed here. For any input x, the first thing we would do is we would do x squared. Now, no matter what our x value is, we can always square a number. And then our next operation is subtract 2. And again, no matter what the number is, we can always subtract 2. Because we can take any real number, square it, and subtract 2, there are no restrictions on what we can plug in. So for that reason, in this problem, the domain is all real numbers. If we were to illustrate this on the number line, we're looking at the entire number line. So in interval notation, we can express this as -infinity to infinity. Let's now look at one last example. Here, our function is f of x equals x divided by 2x minus 3. When trying to figure out the domain of a function, you want to think about operations that you can't perform, because that would impose restrictions on your domain. If we think back to our first example, the operation that we couldn't perform was taking the square root of a negative number. In this example, there's a different operation that we can't perform. Namely, if we're working with fractions, we can't divide by 0. So if the formula for our function involves a fraction, you want to ask yourself, what x values would make the denominator equal to 0? And to answer that question, all we have to do is set the denominator equal to 0 and solve for x. So if we have 2x minus 3 equals 0, if we want to solve for x, we can start by adding 3 to both sides. This gives me 2x equals 3. Then divide both sides by 2. We get x equals 3 halves. Since x equals 3 halves is the only x value that makes the denominator equal to 0, our domain for this function will be all real numbers except for x equals 3 halves. Now, if we want to write this in interval notation, we can illustrate our number line. We can place 3 halves on the number line. And since we don't want 3 halves, we'll put an open circle here, but we want everything else, so let's highlight everything to the right and everything to the left of 3 halves. So in interval notation, this portion of the number line would be negative infinity to 3 halves, and this portion of the number line would be 3 halves to infinity. So in interval notation, we're looking at these two intervals. From our examples, there are two things that we need to watch out for. One is watch out for square roots of negative numbers, and the other is watch out for division by 0. Those are the two operations that will impose a restriction on your domain, at least when we're working with algebraic functions. In this video, we learned that the domain are the inputs to your function and the range are the outputs of your function. And we also learned how to find the domain of functions.